States, and his presentation topic is abnormal ear development in corn, a review.
Thank you for that introduction. Can you see my screen?
Yes.
Perfect, perfect. Thank you very much. Welcome everyone, and I am happy to be invited and be part of this program this afternoon. As you see, my title for today, this is a 20-minute presentation. I will do my best to stay on time here. This is a topic that has increased importance here in the US in the last couple of years. Abnormal ear development in corn. So our project, our team has developed multiple research projects trying to understand some of the underlying factors for these abnormalities. Today, I am coming to you from Ohio State University, and I am happy to share on some of what we have so far. A quick overview of the few stops that I can cover in these 20 minutes. This is meant to be an overview of what we know, an overview of what we have done, trying to avoid any details that might be too specific. But I will share a little bit of a background in corn production and ear abnormalities for corn. And then I will discuss 4 different research phases that we have worked with in the last several years, and then take us down to a few general conclusions. I am glad that Jawad was before me, so that was probably a good introduction for U.S. agriculture. This is a map of the country, and what this is highlighting is the main corn producing states. So in the U.S., we have approximately 37 million hectares of corn production, and a lot of that is concentrated in what we call the Midwest region or the Corn Belt region. This red star kind of denotes where I am. I am on the northeast part of the country, and I have spent almost 10 years in the region. I was in Kansas and Nebraska prior to Ohio, working in grain production, soybeans and corn specifically. That puts us 37 million hectares in the US, top three producing countries of corn globally: US, China, and Brazil. That's kind of the list there. And when we think about corn production in the US, we are not only thinking about corn being grown alone. There is a big component that has to do with crop rotations. Crop rotations for us here in our region is corn, soybeans, or wheat. Those are the primary three crops that we have being grown in the region here, highlighted in green in the map. There is a lot of that, and the most common rotation is corn and soybeans. Not as much wheat. Predominantly, we have corn and soybeans. Here in these states that you see highlighted here, we only grow one crop per year. That's different to other regions in the globe. I am originally from Central America in Nicaragua, and we do two growing seasons for corn in that part of the world. Here in the US, due to weather, cold temperatures, we can only do one crop season, and that usually goes planting in May, harvesting in October or November. So right now we are approaching harvest for when it comes to corn. All of that is to say that corn is a critically relevant crop, not only for us in the US, but also globally. Corn has important implications, uses of biofuels, uses as a feed source for animals, or also used as a food source for humans. And besides those three main areas, there are also several other industrial purposes for corn, for instance, plastics, bioplastics. So there is a lot of interest into this crop, and that sets the stage on the importance of this crop. The topic I am covering today is looking into reports of abnormal ears on the crop season of 2016. That's already a few years back. Several fields, farmers, and industry representatives were reporting widespread concerns of abnormalities like those pictured here. Think about it. You have 37 million hectares of corn in this country. And then we have all of these highlighted states which had some sort of reporting of abnormalities at different levels. So that's a big thing. That was a big deal at that point, and I will walk you a little bit more on why that's a big deal here. Since the beginning, 2016, when these problems were being discussed, again, from farmer fields, from company fields, we went off with the understanding that abnormal ears were likely the result of interactions of multiple factors. We didn't think that a single factor was going to be responsible for all of this, rather a combination of those. What we knew for sure is that at that point in 2016, there was very limited literature, scientific literature that you could consult to better understand the phenomena. So a lot of studies had yet to happen and start unfolding some of that understanding for these issues in corn. So that's precisely what we did. And something that is important to notice here, corn has been a widely domesticated crop, thousands of years. Corn originated in Mexico and then it spread globally. Now we have more than thousands of years domesticating corn as a crop, as the crop that we have today here in the US or in other countries globally. What we do know also is that there are well over 100 years of research efforts trying to expand the horizons on corn. Now, what we knew just a few years ago is that although there are hundreds of years in research, still there are physiological and production questions that we didn't have the answers. This is, if you think about 2016, the precursor of all of these projects that I am presenting today, a series of projects, the precursors were issues like this one's pictured here. This is what was being reported. If you are a farmer and you go out to one of your 50, 100, 300 hectares fields, you go out there and you come across these kind of issues before harvesting, that's a big concern. They don't only look ugly. There is also important implications on productivity. I will show some more of that later today. There are implications on profitability. You are producing less grain, you are producing lower quality grain, and all of this ties back into the sustainability concept that involves social, economical, and environmentally implications that we need to think about if we are losing productivity and yield. So that's a little bit, that's what brought us here. That's what brought us to this topic, and the series of projects that I will present moving forward here in the next few minutes is a summary of my PhD program when I was completing my PhD requirements. My whole research agenda was addressing abnormal ears. So we developed a sequence of projects, and we started first, we went back to the basics. How ears develop in a corn plant, how yield is being determined, how and when, as well as how abnormal ears might be the result of that process. This is the first publication that we got out of that work. Is all of this work is open access. I cannot go into details, but if you are interested in details, if you have seen these issues, if you are interested to learn more, I will invite you to visit some of our publications. You can just type my name and abnormal ears in corn, and you should have the multiple options. This is all open access, so you should be able to open those up from anywhere without a fee of any sort. So this was the first publication that we got out there, and basically we were looking at abnormal ears with the conceptual understanding that it was a result of an stress. And a stress to the plant that could have been biotic or abiotic, and that holds true. There are biotic or abiotic factors that can lead to some of the abnormalities that we are discussing today. The other thing that is critical is the timing. When is the stress taking place? Is that happening towards planting season, or is that happening towards harvesting season, or anything in between? We know that physiologically, the crop is growing through a series of processes during the growing cycle. And depending on when the stress is affecting the crop, that leads to different outcomes, including different abnormal ears. Some of the environmental factors that we need to think about, extreme weather. Extreme weather, we have it here and we have it in other places. This map here on the top right of the slide is an example of a drought monitor map in 2012. 2012 was a very dry year for the US. This map is showing conditions from August. August for us here is flowering time for corn, and flowering time is when the crop requires the highest amount of water. So this drought that affected us in 2012 was a catastrophic event. We had very low yields, very problematic year for growers, for farmers here in the region. And some of that could have been responsible for abnormal ears that we might have seen in that year. Besides drought, we need to think about other stress sources that come out of Mother Nature. Some of that can be cold weather. Planting season for us usually is right after the cold weather, like right after the winter month. So we need to think about that. Some regions are affected with the opposite: excess precipitation and flooding. Flooding in your crop fields when the crop is trying to germinate, that's not a good thing. There is also heat stress. There is also wind storms that we get here in our region. There is hail damage. There are freezing events as well. So all of those could be stress sources that could potentially lead to abnormal ears. The second factor that we summarized, that we looked at, is solar radiation. This is more of a passive process through the crop cycle. It's not as abrupt as a hail storm. Solar radiation is the accumulation of the light interception, light availability, light quality through the crop cycle. We know that we need light for photosynthesis, and that usually correlates well with production. So if we don't have the right conditions in the right periods of that crop, we might be seeing some of the abnormalities that we are talking today. Some studies back in the 60s, late 60s, they were looking at shading corn crop and see what happens. And what they found, no surprise, there were abnormal ears were developed as a result of that. Some of the key findings of that first summary is extreme weather certainly can play a role as an stress source, as an stress factor. We know that primary years in a corn plant, primaries on the top can be avoided. They can fail, and then the plant usually goes to plant B, which is one node below, to develop what we call secondary years. And we also knew that there was an interaction of issues here happening here. Our second project was summarizing the different ear symptoms. When we think about abnormal ears, that's a very general statement. Abnormal ears can be many things, and up to today, we have categorized 13 different abnormal ear symptoms. That's what we did in this publication. We have some nice visuals, graphics that you can consult. We have tassel ears, we have arrested ears, we have fasciated ears, pinched ears, beer corn ears or blunt ears, incomplete kernel set, silk balling, banana-shaped ears, zipper ears, and tip back ears. Those symptoms have been reported historically. This table summarizes kind of the factors and the timing. They have been summarized historically, but we haven't had necessarily widespread concerns. Now, the widespread concerns that we are talking about are three new symptoms listed in this slide, relatively new. Multi-ears is when you have more than one ear on the same node. Barbell ears is when you have gaps of grain in that ear at multiple locations, multiple placements. And the third category of widespread concern is short husk ears. Those are ears that have grain exposed to the environment and to insect and disease pressure. So we don't want any of this happening in our fields. That takes care of the categorization, and don't worry about those names. Those are kind of tricky, and those names might be different depending on where are you located. Those names might change. However, the resource is there. One other project that we went on back at the time in 2016, when there was a lot of concern from grower fields, we conducted what is a field survey. Similar to the previous presentation today, we go out and we work with farmers. Farmers that are facing the problem, farmers that have questions about it. We go out as university, we partner with them, and we try to develop research that will hopefully help answer the questions and come up with recommendations to mitigate issues in the future. This field survey was 15 Nebraska farmer fields. This was in the state of Nebraska, one of the most affected states in 2016. And this is a summary of what we learned from that experiment. Key findings, basically we found close to 80% of ears were still normal. That's good news. Now, bad news is about 20% of the ears in those fields were abnormal or of any kind, any category. However, there could have been fields, we found fields that had up to almost 50% of abnormal ears. That's every other plant with a failed ear. That's not good. And here I will show you why in the next figure. In this case, we looked also at the plant architecture, ear placement. Normal ears are usually higher in the canopy. Abnormal ears are usually lower in the canopy. Why is that important? It's not an aesthetic concern, it's a production concern, and we have it here. Normal ears produce close to 200 grams of grain. Abnormal ears only produce about 20 to 100 grams. If you put that in perspective, that's 60–70% of grain loss in ears that have abnormalities. So that's something that we don't want to see, and that put us on the road for our future projects. And those are the projects that we completed after 2016. And what we were trying to do is to think about in a system level. We needed to consider genetics, we needed to consider environmental conditions, as well as management practices. And that's exactly what we did. And some of our future projects looking into this, one of the questions we were trying to answer was, we were trying to confirm if hybrids environments and seeding rates had a strong association with abnormal ears. This is one of our first G by E by M projects, genetics, environment, and management. This work was done in 2 years, 4 different locations in Nebraska. We partnered with a seed company and a few growers, and we established experiments, replicated experiments in Nebraska fields looking at the abnormal ears. Key findings. We were able to successfully prove that ear abnormalities are the result of interactions of the tree. You can have susceptible hybrids. You need to have a stress source out of the environment, and seeding rates can change the dynamics. If you have too high seeding rate, that's more competition in the crop, and that also adds up to the stress and to the results of abnormalities. We also learned that we had 5 times higher yields when we had no abnormalities. Basically, a crop that was clean of abnormalities maximized yields up to 5 times higher yield. So hybrid selection in this case was an important piece out of this project, and finding optimum seeding rates was also an important piece as a way to maximize crop yields. The next one here, next project, we confirmed seeding rate is a factor. We wanted to look at planting dates. If planting dates had an effect on these abnormalities, this is a different project, an independent project, 2 different locations, 3 different years. And some of our key findings, we confirm again, genetics, environment, and management practices as part of the issues. We had approximately 7% of abnormal ears. Significant effects were detected, 4 times higher yields when you don't have abnormalities. And in this project also, hybrid selection was key, as well as optimum planting dates. If you are planting too early, can lead you to stress. If you are planting too late, can lead you to stress. So you want to find that optimum planting window. The summing up of all of this work is abnormal ears affect cornfields. It did a few years ago, many years ago, or hundreds of years ago. It still affects cornfields today. Every year I get phone calls of reports with some of these abnormalities anywhere in the US, as well as in other places as well. Abnormal ears decrease grain yield. You can expect damage to grain quality as well. The selection of resistant hybrids, as well as coupled with optimum management practices, can help to mitigate and manage these issues moving forward. Plant morphological characteristics, plant architecture can be a diagnostic tool to understand plants with normal ears versus plants with abnormal ears. And finally, we have 100% confirmation that hybrids susceptibility has something to do into all of these. Stress factors from the environment have something to do with this, as well as things that we have in our control, like management practices. Those are things that we can change. Those are things that we can modify, and hopefully be able to mitigate or manage abnormal ears here in the future. That's all I had for today. I will say thank you and acknowledgement to our research partners, multiple universities, multiple seed companies, as well as the Water for Food Global Institute. They were supporters of our work. And I will be happy to take any questions if there are, or if not, I can be contacted via email anytime. Thank you. Are there any questions?